This video that I'm recording here will be my presentation on why I believe that the second law of thermodynamics is wrong, that entropy doesn't increase with time, with entropy being the measure of randomness and chaos throughout reality within an isolated area of space. All of my work that all this will be based off of will stem from two books that I've published. The first being the third book that I published, called Quasi-Dimensionality, an accidental blueprint of the Infinite Improbability Field, with the rest of everything that I'm going to cover here being present in my second book that I published called Metaversal Decipherment, The Art of Meaning Mechanics. I don't have that book with me, but both books, the link to both books will be in the description below. Now this will be the table of contents showing everything I'll be covering throughout this video. What is a wavelength? What are shadow particles? How do shadow particles show up in the structure of particles? And how do they differ between particles of matter and nodes of light? What is the spin of a particle? What causes the particle to spin? What is the Doppler effect? And how will the Doppler effect serve to increase or decrease the likelihood for particles to be dragged down by the presence of another particle? How are photons able to project two-dimensional renditions of the object of matter that they were emitted from by having that projected rendition of the object land on the surface of something else as that which is two-dimensional? How are black holes able to capture photons? What happens to particles once they are caught within a black hole? What is computational irreducibility? What causes computational irreducibility, and why it's relevant to explaining that the second law of thermodynamics is wrong or partially right within a certain context at best? And lastly, how is it possible for us to get around the limits brought on from there being computational irreducibility? Now, with that out of the way, let us begin. What is a wavelength? The wavelength is typically seen and treated as a conceptualization device for physical phenomena and not as something which is physical unto itself, meaning that the wavelength is designed to represent how physical interactions in nature are measured, such as the amount of pressure present within a heartbeat, and how the rate of increases and decreases in pressure will determine the overall frequency of those heartbeats, or in the case with physics, the wavelength, which comes in several forms, with the most commonly recognized form being the sine wave. And the one that I'll display in this video, due to the sine wave being comprised of a curvature pattern, is formed by having the rises and peaks. The rises or peaks in its patterning to represent an increase in the energy level of the particle, as the dips will show a decrease in a particle's energy levels, thereby making the amount of repetition in that rise and fall dynamic to occur within a certain amount of time to be the frequency of the particle. On top of that, when the wavelength is shown to be more elongated, then the frequency of the particle will be less than when the wavelength is more compact and shown to have more repetitions in the increasing and decreasing of the particle's energy levels. As you can see within figure 1a, you have a wavelength through a sine wave wavelength, with this representing the increase and this representing the decrease in the energy levels, with the amount of increasing and decreasing over time to determine the overall frequency of the wavelength. While here in figure 1b, with the increasing and decreasing being more compact, you see this representing a higher frequency wavelength. So you see the more elongated form, and you see the more compact form, higher frequency, lower frequency wavelength. What are shadow particles? Because the particle is assumed to have just one wavelength, what most physicists tend to not realize is that the particle is comprised of an infinite amount of wavelengths, with the wavelength which is usually deemed to being the sole wavelength of the particle as being the source particle relative to the shadow particles, which are to serve as projections of a sort, by having the source particle, if we just so happen to gauge in music theory for a moment, function as a particular key, and to be more specific, the middle octave of the musical within the musical scale, like middle C. Now as for where shadow particles will show up within the structure of a particle, the best answer would be the in-between spaces within the initial or source wavelength. That way, the shadow particle will be able to retain a similar shape to the source particle or wavelength, all while being its own thing, which means that the shadow particle will be in the same key as the source particle, but in a different octave, with the octaves of these keys going on forever, because the wavelength within a wavelength pattern is surely to continue without there being an end to it. Now, as you see here in figure 2, you have this right here representing the initial or main wavelength, the wavelength at its highest point, which you can just imagine it being like this wavelength right here. This right here, you can call this key C, or within middle C. While in between those rises and falls, you have the shadow particle. This is key C, but in a different octave. And within each one, you have the same key C appearing over and over again throughout forever. What are shadow particles? Well, I already covered that, all right. How do shadow particles show up in the structure of particles, and how do they differ between particles of matter and those of light? Particles of matter will consist of wavelengths which are compact in nature, while photons, maybe even bosons in general, will consist of wavelengths which are more sparse, and how often they'll show up within such a particle. For it's the contained space which makes up the localized field of energy that the particle, which necessitates the use of a thing within mathematics called the Poincare disk model, where a set area of space will have the means of containing within that space an infinite amount of renditions of the same shape, and with each shape being of the same size, with the caveat being that the observer of this phenomenon or configuration will need to zoom in on a pattern in order to see each of these shapes as being of the same size, which is something that we'll come back to. And given that these waves are infinite in number, the only way for them to show they are all existent within this space would be for the perceived size of the wavelength to enlarge in, the closer it is to get to the center of the particle, with the need for the wavelength to do the opposite, at least from the perspective of the observer, once the wavelength is to begin its journey towards reaching the other side of the particle. Now, as you can see here in figure 3, you have that of matter. The wavelength bands, as I call them, are more compact within the space. And let's say the largest wavelength, or what you would consider to be the source particle, which everything else being shadow particles until they move through the space and become that source or main wavelength that we're calling here, let's say middle C, though it doesn't have to only be C. But whatever it is, whatever key is in, this will be the middle, within the middle octave, within the musical scale. This is how matter forms. While for light, in any particle that represents energy, the wavelength bands are more sparse, meaning that it shows itself up, it appears less frequently. So there's more space in between them. It's less compact, and that's why light is different from matter. What is the spin of a particle, and what causes the particle to spin? Particles are known to rotate, with their rotation in one direction being labeled a zero in the other direction that a particle might rotate, being labeled a 1, as both labels are what serve in the foundations of binary code, which is a code used within the deciphering and programming of data, though for the cause of their rotation, along with the purpose that it serves for them to do so, is the wavelength of a particle, despite there being a distance between particles. From the outside looking in, will bridge that gap and have this wavelength come into contact with the wavelength of another particle by having the position of the particle arrange itself within the exact angle needed for the particle to align itself to the position of the other particle. For this will cause the wavelength belonging to each particle to make their attempts at absorbing the wavelengths of the other into their host of wavelengths, which is what the attractive component of a force is based on. With the failure to do so, to stem from the angle of the incoming particle's wavelength being off within enough of an extent that the particle it was aiming to be absorbed by would cause the wavelength to bounce off of it, as the force from that would push the particle to rotate within some capacity, which is not only where the repulsive component of a force comes from, it also is the reason why the wavelengths of a particle will reside within a confined area, the spin of the particle as the force which contains the wavelengths, so as to allow for a discreteness with the connectivity of each of their wavelengths to span any distance to allow for the continuity of wavelengths to exist as well. Now what you see from figure 4 here are two particles that are rotating, they are spinning. One you call a 0, another you call a 1. If you see a particle spinning within a counterclockwise motion, I imagine that the waves will flow from the bottom to the top if it's moving in a counterclockwise motion. While if it's moving in a clockwise motion, then you'll see the waves flow from the top to the bottom. And to continue on with that segment, the other reason that the spin of a particle is crucial to the sustainment of physical reality entails the two-dimensional nature of a wavelength, with the 2 degrees of freedom that it has, even though the wavelength is made out of a one-dimensional object, as in a line, being the only thing which forces the need for particles to spin, since it's the spinning of a particle which enables a particle to know the location of a particle, if having a particle turn sideways will make their wavelengths invisible, yet still existent. Because as you see here, in an actually two-dimensional form, if you turn to the side, you can't see it because there's no depth. But as you turn it forward, you can see the wavelength. What is the Doppler effect, and how will the Doppler effect serve to increase or decrease the likelihood for particles to be dragged down by the presence of another particle? The Doppler effect is something which occurs when an individual will experience the sound of something increasing, the closer that they are to get to the object, to it. While the further away they are from it, the quieter the sound will be. And since sound is caused by vibrations in the air, which means waves being sent through the air, if the closer that one is to get to a wave, the larger the impact it will have on them. Then if a particle were to get closer to another particle, what would emanate from that would be an increase on the forces being enacted by the particle, such as the pull that each particle would have on each other, as well as the pushing away of each particle. But if I were to hone in on the very thing about a particle, which causes it to slow down the velocity of another particle, I would say that it's when the wavelength of a particle is reaching into the in-between spaces of another particle, which would be one of the moments when a particle's wavelengths are not in the way, as that exact point in time would allow for the incoming wavelength if it is of a different key to the one that the receiving wavelength is in, to disrupt the flow of the particle's wavelength, overall leading to the particle slowing down, with the photon having the least amount of chances to experience this, given the sparsity in how many wavelengths will show it within a certain amount of time. Now, as you can see here, when two particles are near each other, like for instance, matter and light, when they are aligning each other, like for instance, if it was further away but still able to essentially be over it, therefore touching it, from a sense, from a perceptual standpoint, from the perspective of the particles that they are touching, that in turn would allow for the photon, basically the wavelengths of this of a particle right here, to enter through this space. And if it's entering through this space, or for instance, matter and matter, the wavelength of matter right here, if it's of a different key to the matter of this particle, let's say light or any other matter particle, would disrupt the flow of the wavelength, causing it to slow down. How are photons able to project two-dimensional renditions of the object of matter that they were emitted from by having that projected rendition of the object land on the surface of something else as that which is two-dimensional? Now, as far as my mentioning of the sparse arrangement of wavelengths which make up the photon, I believe that it's this particular feature of the photon which causes light to only project itself onto a two-dimensional surface as something that's two-dimensional, even if the image is of something which is three-dimensional. For if the photon were to have large enough spaces within itself to allow an influx of wavelengths from particles of matter to enter into and through the photon, then the photon would have to act as a tunnel for the pouring in of two-dimensional objects, and with that, the imprinting of information onto the photon from those wavelengths due to the photon showing in real time what is taking place within it. Now, going back to what I said before about the wavelengths of matter going into light and interfering with light, because there's so much space when it comes to the wavelength bands of light, if matter were to go through that space, the wavelengths of light will pick up on that and transmit the wavelengths going through the light like it's going through a tunnel. And that's why you see basically light transfer information through it of matter, transfer information of matter through light. That's what's happening there. Light is carrying or holding the wavelengths of matter and allowing the transfer to flow through light in real time. How are black holes able to capture photons? Because black holes are formed through an excessive accumulation of matter, when the absorption of wavelengths have aided in increasing in size of an object's wavelengths, with that size being so great that the sparse configuration of a photon's wavelengths would prove ineffective at being able to prevent the wavelengths of a black hole from disrupting the wavelengths of a photon. The only thing which can come from that would be the photon's captivity. So basically, it's a lot easier for a black hole to capture matter because the wavelengths are more compact. But because the wavelengths of a black hole are much larger and more impactful, regardless of their distance, and even though light has more space between them, so they can evade being affected by the wavelengths of other particles more so than how matter would be, a black hole would still be able to capture a photon and suck it into a black hole, essentially, despite the distance between each wavelength band. What happens to particles once they are caught within a black hole? If shadow particles are both the future and past iterations of the source particle, as the passage of time would eventually cause the overall size of that source particle's wavelengths to shrink, while having its proportions remain the same, then by their being an object with the need to attract onto itself an influx of wavelengths in order to sustain itself, such as with a black hole, the particle which ended up being pulled into the black hole would find itself being crushed by the overwhelming power regarding the level of attraction that the black hole would have on the wavelengths of the particle, which means that the collapsing in size of the entire particle. So in the same way that the hypercube or tesseract, which is a four-dimensional object with the fourth spatial dimension being that of size, as in all of the other spatial dimensions combined, thereby making the size of the object the fourth spatial dimension, along with the fourth dimension within space-time being time itself. I believe that by collapsing the entire size of the particle through the use of a black hole, just like how as time moves forward, the wavelength of the shadow particle will increase in size until it reaches the middle portion of the particle, only for it to again decrease in size or begin its process of decreasing in size for the first time. The particle being crushed by the black hole is not having its information destroyed by the black hole. It is being sent to another time period, since our notion of time is determined by having particles which are relatively of a similar size to each other, which is what allows for the tracking of time to occur between them. But if the particle was small enough to fit within the spaces between each wavelength of a regularly sized particle, then its velocity wouldn't be dragged down by the presence of those particles, which means that the detection of that particle wouldn't happen, for starters, as well as the speed of the particle reaching faster than light states, with the final point in all of this being that the particle would become either that of dark matter or dark energy, given the type of particle that it was by the time it was consumed by the black hole. Now, as you can see here in figure 5, you have here a conceptualized form of what a tesseract or hypercube would look like, with the outer cube and the inner cube here, which they are connected to. The inner cube here represents basically what the fourth dimension actually is, which is size. The entire size of the cube shrinking down and enlarging, with rotation occurring within a simulation of a hypercube to show the inner cube enlarging and the outer cube shrinking, and that whole dynamic occurring continuously whenever you see the rotation of a hypercube simulated. What is computational irreducibility? I'm first going to start off with the official definition of computational irreducibility. Then I'm going to explain what I think it is. Computational irreducibility suggests certain computational processes cannot be simplified such that the only way to determine the outcome of such a process is to go through each step of its continuation. Now, how I see it. Which means that you have to know how something works to be able to know how to skip ahead and just figure out what the problem is, what is going to happen next or towards the end of something, if we are engaging in a story of some kind, for instance, thereby making the issue of computational irreducibility an issue with needing to go through certain experiences, no matter how tedious it might be to do so, in order to learn how to move through experiences of a similar nature with greater ease than it would have been for us had we had not undergone the things which led to our understanding of that thing. What causes computational irreducibility and why it's relevant to explaining that the second law of thermodynamics is wrong or partially right within a certain context at best. The reason that there is computational irreducibility is because the more that you try to reduce the particulars of a system to a finite or specified group of components or factors, the greater the energy or information is added for that system to compute, which leads to even more results to emerge out of any computation taking place within that system. This also means that any system designed to formalize the dynamics or mechanics of that system, such as with the case of a numerical system, which means mathematics as a whole, would then lead to problems with being able to neatly arrange an entire system in such a way that everything within it works out without paradoxes, conundrums, or loose threads to tie up, or tighten, if you will. For the more information that we have about a system, the increased means to engage with that system efficiently, but for an improved way to handle a system comes with that methods which are more complex than they would have been otherwise, which leads to the idea that with greater order comes with that an opening for greater means of chaos, which is also why the opposite of that must also be true. In the last segment of this video, how is it possible for us to get around the limits brought on from there being computational irreducibility? Before anything else, it would be of the utmost importance for me to explain what quantum entanglement is. For it's a phenomenon within quantum mechanics which states that across any distance, two particles can become synchronized in their spins, where if one particle were to have its spin changed, then the other particle's spin would change at that very moment, which violates the law that nothing can travel faster than the speed of light. Yet what isn't realized about particles is that their wavelengths can interact with each other, even if they are light years apart, as this feature of reality would enable the wavelengths of several particles to resonate with each other, just as long as the key of those wavelengths are the same, which includes the octave being the same. This way, the shock wave of the change in the particle's spin will reverberate across space-time at a rate which exceeds the speed of anything else, because the shock wave is actually a wavelength copy of the wavelength that these entangled particles are made out of, as the shock wave wavelength will mimic what wavelengths within a particle are prone to doing, which is to decrease in size as soon as the wavelength moves away from the middle spot of the particle. In other words, the location of the particle whose spin change would essentially function as the side of the particle where the wavelength collapses, while the midway point between both particles will signal the wavelength to expand until it reaches both the size of the other particle's wavelength and its location. The other way that a particle is able to change the spin of another particle through quantum entanglement involves the particle acting as its own portal to future and past versions of itself. Since every version of that particle is present within the particle as a shadow particle, which means that the space that the particle would occupy within any point in time would also exist within the particle. On top of that, because every possible version of a particle exists within that particle, it's through the overlapping wavelengths which make up a particle, which then enables these wavelengths to take portions of each one and have those portions connect to the formation of a to have those portions connect to portions from different wavelengths within the same particle, as the mixing and matching of these portions would lead to the formation of a composite wavelength. With this kind of wavelength having the capacity to match the frequency of any other particle, which means the entanglement of every particle and not just a single one. Furthermore, by having the formation of these wavelengths add in their complexity, such as the transition from the regular wavelength to the shadow wavelength, and from the shadow wavelength to the composite wavelength, the simultaneous increase and decrease of complexity within a system as time moves forward, given that dark matter and dark energy are particles which represent future iterations of reality. As the closer that we get to the point in time that they are a part of, the more particles that will expand in wavelength, so as to take up more space by having the size of their wavelengths increase as the size of our wavelengths decrease with time, due to the pressure being put on us by the continuous emergence of particles across space-time. Means that it's through the presence of particles which operate outside of our notion of time that we are able, through the presence of particles which operate outside our notion of time, that we are able to go around the restraints placed on us by computational irreducibility, with the help of receiving information from a time that we have yet to encounter. After all, to have information instantly transferred to any location across time and space will be to realize that with an increase in complexity within the functionality of a system means that the appearance of chaos or disorder from the perspective of those who aren't familiar with utilizing systems with the same level of complexity, which is what happens when the mathematical patterns seen with Newtonian mechanics are far from having any application within quantum mechanics, because the mathematical patterns are looking more like the numbers used in the calculations are entangled with each other. Similarly to how particles would experience themselves being entangled, that numbers within such a system would allow for the immediate recognition of the correct answer or necessary paths towards success, regardless of how it might seem to be from a perspective more used to discovering a solution through a conventionally linear thought process. Hence the idea that anything from systems to spatial dimensions, which utilize a more complex approach to handling things, will always come across to the naked eye as more disordered and unpredictable. Now, essentially what this means is, when it comes to the formation of composite wavelengths, is with these overlapping wavelengths, you have this, and you have it go here, and then change here, and go here. Let's say change here, and change here. So it creates this mixing and matching of these wavelengths within a particle, which changes the key that it would have been in due to the formation of that composite wavelength. That's what a composite wavelength is, essentially. That in total is everything I have to cover in this video. If you want to know more, which I get into more in depth within both my books, you can find them in the description below. I hope everything that I described here at least gives you some inspiration to seek out more information I have on these topics.